Have you ever wondered what happens when you click run on a Java program? How does Java magically work across Windows, Mac and Linux without any changes? Imagine you wrote a letter in English but your friend only understands Spanish. Now you would need a translator to make sure they understand your message, right? The JVM, Java Virtual Machine, is like the translator. It converts Java's universal language, or you can say bytecode, into something your computer understands. But now the question is how it do that. So in this lecture I am going to teach you how it do that. What we are going to learn in this session: first of all, what is JVM, second, what is JRE, third, what is JDK, fourth, how JDK, JRE and JVM runs together, fifth, the most important, differences between JVM, JRE and JDK. Understanding the differences between these three pillars of Java, we will be able to answer any question related to Java Development Kit, Java Runtime Environment, or you can say Java Virtual Machine. Today we will break down the three pillars of Java: JVM, JRE and JDK. By the end of this session, you will know exactly how Java works under the hood and why it's called write-ons, run anywhere. So let's start. Java Virtual Machine. Java consists of three core components: JVM, Java Virtual Machine, JRE, Java Runtime Environment, and JDK, Java Development Kit. Each of these three has a distinct role in execution of Java programs. First of all, Java Virtual Machine, the execution engine. The JVM, Java Virtual Machine, is an abstract machine that provides a runtime environment for executing Java programs. Now, why it is called an abstract machine? Abstract means that you cannot see the hidden structure of that. Abstract means that it is hidden. You cannot see how JVM is working. For that reason, it is called an abstract machine. It converts Java bytecode into machine-specific instruction for execution on different operating system. It converts the Java bytecode compiled by the Java compiler into machine-specific instruction, the machine code that your system only understands, for execution on different operating systems. JVM workflow. First of all, class loading. The JVM loads compile.class file which includes the bytecode. Java workflow. First of all, class loading. The JVM loads compile.class file which includes the bytecode into the memory. Then, bytecode verification. The JVM checks periodically if there is any issue with the bytecode. Just-in-time compilation. The JIT compiler converts bytecode into the machine understanding machine code for faster execution. Fourth, execution. The converted code runs on the different system processors. Fifth, garbage collector. Look, Java has a built-in feature called garbage collector. What it does, it periodically checks if there is any object which is unused in your source code, so that it can deallocate the memory automatically. But in C or C++, you cannot do that. You have to do some certain tasks to deallocate the memory. JVM is included in both JRE and JDK. Java Runtime Environment. The JRE provides everything required to run Java applications, but not for development. What does this mean? It doesn't have the development tools like the compiler, debugger. JREs consist of JVM plus libraries to run the Java applications. What JRE includes? First of all, JVM to execute Java programs. Second, core Java libraries, or you can say Java APIs. Now there may be a question that what is API? API is nothing but application programming interface, is a set of rules or protocols that allows different software applications to communicate and exchange data. Third, configuration files for Java execution. Look, JRE is just a subset of JDK. It does not include development tools like compilers, debuggers. Java Development Kit. Finally, let's talk about the JDK, Java Development Kit. This is where the real magic happens. For Java developers, if you want to write, compile and run Java programs, the JDK is your best friend. What JDK includes? First of all, the JRE, so you can run Java programs, providing a secure runtime environment, a compiler to turn the Java code into the bytecode, JavaC compiler, development tools like debugger, documentation generator and more. In the future, when you will write large complex program, you will need this debugger. JDKs consist of JRE plus compiler plus development tools, and this JVM is included in this JRE. So overall, JDK includes everything. JDK includes both JRE and JVM, making it the complete package for development. Now, let's imagine a real world analogy. Suppose that you are in a restaurant. You have ordered some food. The chef or cook, whatever you say, is preparing your food. The chef is the JVM. who made the ultimate product that can be served to you, the user. Now the chef is using oil, masalas and many other things to prepare your food. The chef, the masalas and the other necessary things are called JRE. And the chef is cooking your food inside a kitchen. This whole kitchen setup is called a JDK. Now what does this mean? The chef is the JVM who is using many necessary products to make your food. The chef and those necessary products combinedly called JRE, and the whole kitchen setup where there is recipe book, there is fridge, there is the chef, everything else. The whole setup is called the JDK. Now focus on this table like structure. There is 4 columns and 5 rows. First column for feature, second column for JVM, third column for JRE, fourth column for JDK. What the first row says? Runs Java program. Does JVM run the Java program? Yes. JRE? Yes. And JDK? Yes. But how? Because all of these 3 things has JVM, Java Virtual Machine, that compiles the bytecode into the machine code. Converts bytecode to machine code? Yes, 3 of them, because all of these 3 have the JVM. Now the third includes code libraries. JVM, does JVM has any library? No. JRE, yes, it has libraries. JDK, yes, it has libraries. Fourth, includes compiler. JVM, no, it doesn't have any compiler. For that it is no. JRE, no, because it also doesn't have any compiler. It doesn't have the development tools. JDK, yes, because it has the compiler, debugger. Fifth, includes development tool. JVM doesn't include any development tool. JRE also doesn't have any development tool. Yes, JDK has the development tools like the compiler, debuggers, documentation generator, etc. Hope so all of you have understand the table. Now, how JVM, JRE and JDK work together. First, developer writes source code. Here you are the developer who is writing the Java source code. Second, compiler converts the source code into the bytecode. The Java compiler, JavaC, converts the source code into the .class file which includes the bytecode. Third, JVM inside JRE runs the bytecode because JRE provides the JVM and libraries. Fourth, JVM translates the bytecode into the machine code. Then the program runs because your system only understands the machine code. See, you are writing a Java source code. The extension for that source code is .java. Then it goes to the compiler JavaC which converts the source code into the bytecode. Now a .class file which includes the bytecode is created. Look, this .class file or bytecode is platform independent. It doesn't depend on the operating system you are using. It can be Mac, it can be Linux or anything else. It doesn't depend. There is a problem. The arrow will not be here. The arrow will be from here to here. See, the .class file which includes the bytecode is platform independent code that goes to the Java Runtime Environment. The JRE has the JVM. What does JVM do? It converts the .class file or bytecode into the machine code that your machine understands and your program runs or executes. This is how all these 3 things work together. First of all, you have created a Java source code. The extension for that source code is .java. The JDK, which has the Java compiler, JavaC, converts that source code into bytecode or .class file. That bytecode goes to the Java Runtime Environment, which has the JVM and JIT. JVM converts the bytecode into the machine code, OS specific code, which your system understands. Then your program executes. See, here I have created a Java source code. The extension for that file is .java. When I compile that source code, that is compiled into bytecode. The extension for the bytecode is .class. And how I do this? By using JavaC compiler, which is included in the Java development kit. Now, this .class file goes to the JRE, which has the JVM. The JVM converts this .class file or bytecode into the machine specific code. Then your program executes and you get the proper output. Now see the full workflow. You have created a Java source code. That Java source code is compiled into the bytecode by the JavaC compiler, which is in the JDK. Now see the full workflow. You have created a Java source code. That Java source code is compiled into the bytecode by using JavaC compiler, which is in the JDK. Now this .class file or bytecode goes to the JRE, which has JVM. The JVM converts the .class file or bytecode into the machine code. Now your machine understands the code and give you the proper output. This is how JVM, JRE and JDK work together. Look, JDK is the complete package, which includes JRE and interpreter. Now inside JRE there is JVM and system libraries, or you can say API. JVM converts the bytecode into the machine understanding machine code. Then you get the proper output. See how your program runs. You have created a .class file. See how it works. You have created a Java source code. The extension for that Java source code is .java. Inside JDK there is JavaC compiler, which compiles the Java source code into the bytecode or .class file. That .class file goes to the JRE. Inside the JRE there is JVM. JVM converts that bytecode into the machine code that your machine understands, and you get the proper output. Hope so that you have understand everything. Here is the same thing. JDK is the complete package which has development tools like JavaC, JHeap, JConsole, and inside JDK there is JRE, Java Runtime Environment, which provides a secure runtime environment to run Java program. Inside JRE there is JVM, which converts the bytecode into the machine code. So if you download the JDK, you will get everything. Now the most important question: differences between JDK, JRE and JVM. First of all, take a screenshot of this. Purpose. What is the purpose of JDK? Used for developing, compiling and running Java code. JRE provides a secure runtime environment to run Java applications. JVM, that is the most important part, converts bytecode into the machine code and executes Java program. Includes JRE plus development tool, JRE, JVM plus core Java. JVM, just the virtual machine which converts the bytecode into the machine code. Components, they are all same. Just take a screenshot and remember this. Thank you so much. Hope so you have enjoyed the lecture and be with us. And at the end, I would like to say, just hit the subscribe button, give us a like and give your comment. If you face any problem,